Hello, class. I'm going to do a recording for section 9.5, which is called Applications, Number Problems, and Consecutive Integers. So in your workbook, if you can follow along, beginning on page 119, we'll start with vocabulary.
All right, so one type of problem that we'll be doing in this section requires you to learn vocabulary for consecutive integers, or your problem might cover consecutive even integers, or it might cover consecutive odd integers. So any of these type of problems, you've got to look, have an eagle's eye out and look for this vocabulary. And then you're either going to be working in an equation and manipulating either two numbers or three numbers. Rarely do they have you in this section work with four or more numbers. So it's usually just two or three. But if you look at the vocabulary happens to be identical for the consecutive even integers and the consecutive odd integers. The vocabulary is different for consecutive integers. And you know that when we take our tests, I allow you to use the first sheet of each lesson because it has vocabulary. And so when we take test number 2, you are allowed to have this sheet so that you don't have to have the vocabulary really memorized, but you do need to know how to use it in a time during a time test, right? Because it's a time test. And so consecutive integers, the book says these are integers that are consecutive if each is just one more than the previous integer. So 3 consecutive integers can be represented as n or n plus 1 would be the second representation, and then n plus 2 would be the third. So this n represents the first consecutive integer, and usually I use just CI, just for shorthand writing to save me writing when I list and label. I just put CI, and I'm just using the first letter of each word. The second would be represented by n plus 1, and the third would be represented by n plus 2. Now, if they say where n is an integer. I mean, if you wanted to use x's, you could, x plus 1, x plus 2, but I'll just use n because the book is using n's for that, okay? And so if I give you some examples of those integers, like they said, they increased by 1. So like, let me show you. Like over here, if I start off with, 1, 2, 3, right, and dot, 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 right, in this set, they increased 1 more than the previous. So if you look at 2 is 1 more than the previous, 1 more than 1. 3 is 1 more than the previous, right? 1 more than 2. So these are consecutive, 1, 2, 3. Okay, but I can also go into my negatives, and my number line. These could also be examples of consecutive as well. So they can, integers, are positive and negatives, right? And also 0. Okay, and in this case, consecutive 0 could be included in that one after the other. Consecutive even integers, I'll abbreviate as CEI. CEI for consecutive even integers for my shorthand. These integers, even integers, are consecutive if each is 2 more than the previous even integer. So here are examples of 3 consecutive generic integers. The first one, let it start with n. The second one, let it start with n plus 2. And third one, let it start with n plus 4, where n is an even integer. Okay, so if I were to give you some examples of that in the set notation, and I come over here and I can start with 2, for example, 4, 6, dot, dot, dot. So you see 2 more than the previous. So we look at 4. 4 has a value that's 2 units more than 2, right? 6 is 2 units more than 4. So 2, 4, 6. These are called consecutive, like after the other, but after the other with an increase of 2. They're evens, okay? And then I can put down some other consecutive integers that increase by 2. If I go back and put some of these negatives in, these are also considered, you know, increasing by 2. 2 units, okay? And then for consecutive odd integers, I'm going to abbreviate as COI. And the description is, I think, pretty much identical, except for the word odd. This is even, this is odd. Integers are consecutive if each is 2 more than the previous odd integer. So the only way that it's different is that these are odd, where these are going to be even. But other than that, look at the vocabulary is identical. First is n, second is represented by n plus 2 generically. The third is represented by n plus 4. And it just works out. The algebra just, the beauty of it is the algebra just works out. So just use it. Okay. And if I give you some examples of that, if I start over here, like with 1, 3, 5, ... So you see, 3 is 2 units more than the previous, 2 units more than 1. 5 is 2 units more than 3, right? And so, and then if I go back and give you some others, I could use here -1, -3, -5, and then ... Okay. So yeah, so notice here how I don't include 0 in that list here, okay, because of that increase of 2. Okay, so there is another vocabulary word that I want you to write at the very top. So if you're still writing this down, just freeze it, stop the video and write it down. But I'm going to go ahead and continue at the top, and I'm going to write a formula for a text messaging problem that you do in this section. And I believe a text messaging problem also comes up, I believe, on the final exam. I think we make use of that. So we come over here. We have the formula for the text messages sent. Okay, so that would be this. The initial fee that's charged for the service, plus there's an extra charge because they go over their limit. And we're talking about monthly messages sent. And this is, you know, we talked about unknowns, how I've been highlighting your unknowns. In these problems that they give you, your X, somebody's got to be the unknown. This is the unknown, this variable here, the monthly messages sent. And then we're taking away the first set allowed. Close the parentheses and equals the amount. Okay. So when you will have one problem on your test like this. So you don't have to write, because this takes time to write this formula. You don't have to write this formula on your paper when you take the test. You're allowed to use a sheet, but you just start doing, when you read your problem, you just start putting your substitutions, the numbers in, and you know this is going to be your x, and then your x, and then you're going to just solve it. This is it's a formula for the text messages. This is the formula, but you are going to be solving that, for x, okay? And 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 just remember for this test number 2, we want you, when we're working with these applications, we want you to set up the problem as an equation, and then we want to see you solving. And when you solve, we want to see you applying those procedures. So don't fight it. Learn the procedures. Do you have any distributive property? If so, do that first. Do you have any combining like terms? If so, do that next. Do you have any terms where you can add or subtract terms to move them? If so, do that third. Last thing you do, fourth, is either the multiplication principle, where you multiply by the reciprocal on both sides if you have a fractional coefficient. Or do you have a coefficient that's a decimal or a coefficient that's an integer? Because if so, then that's easier. You just divide. You divide by itself. Divide both sides by that number, whatever that number is. Okay, and then you label. If you have to label, is it feet? If we're talking about trees, are you labeling feet? Are you talking about a formula and you got to keep track of the units? Like a geometry formula or something where you keep track of your units, for example. But we want to see you setting up equations and then solving them. So a lot of times students try to solve, I guess trial and error, and they might get the right answer, but then getting the answer is not the only thing that we're looking for, right? We want you to set up equations and solve them. So we're looking for procedure. So just keep that in mind, because in this course, you're supposed to be learning that. You're supposed to be learning that, learning how to set up equations, learning how to solve. So remember, that's our goal, okay? And so just remember that when you show your work, I'll be looking for that. Your work has to be familiar to that, look like that, okay? All right, so then let's start. There are other types of problems that we're going to do, like, for example, number problems, and there's other types of problems too that we're going to be doing. But the first ones we'll cover are going to be the consecutive, even, consecutive odd. So we'll start with those first, and then we'll do the text problem, and then we'll do some of these number problems, and I think there's a couple other type we'll do also, okay? But let's start with those consecutive integers. Oh, and actually there's some vocabulary. Let me go through some of this vocabulary since we're recording this. This is on page 120. Let's see what they have here. So remember, I have a teacher's edition that they have answers down here, but let's see what they're talking about here. If an odd integer is divided by 2, they're saying the remainder will be 1. And is that true or false? Okay, well, the only way to show that, think about if it's true or false, is to actually do that. Think of an odd integer. So think of, like, for example, 7, right? 7 is odd. So an odd integer, example of that would be 7. Okay, now divide it by 2. 2 goes into 7 3 times. 3 times 2 is 6. And look at the remainder. That's your R. And they're saying that when you take an odd integer and you divide it by 2, the remainder is going to be 1. And that looks like that's always going to happen. If you think of another odd integer, like 15 is considered odd also. 15 divided by 2. 2 goes into that 7 times, that's 14, and 1 left over. Yeah, so that's enough. Seeing a couple is enough to say, yeah, that looks like that's true. Okay, this one. To find 3 consecutive odd integers, you should use this vocabulary: n, and then n plus 1, and then n plus 3. So they're saying that n would represent the first consecutive odd integer. They're saying n plus 1 would represent the second consecutive odd integer. And they're saying the third should be represented, n plus 3, as the third consecutive odd integer. Okay, well, let's, and right here, the book is saying that that's false. And let's see why. You want to go back to your vocabulary sheet and you want to look up consecutive odd integers. And when we go to that here, we're on, this is page 119, consecutive odd integers. This is what they told us to use: n, n plus 2, and n plus 4. Is that what they use? N, okay, that's good. Okay, nope, there's an error there. N plus 1, nope. N plus 3, nope. So that's why they say it's false. You should be using n, n plus 2, and n plus 4, okay? So you got to use your vocabulary, okay? All right, okay. Oh, and let me do this problem while we're at it. This is a good one to do. This one, they're probably, you know how I want you to do 15 minutes in your Learn. So this one, they're probably going to show you this in your video, but this, I like to show this one too. This is on page 120. Okay. So Jim plans to budget 3/7 of his monthly income to send his son Taylor to a private school. So I like showing this one because it uses the word of, and I like to demonstrate that oftentimes in math, the word of can mean to multiply. Okay. And we don't know his monthly income. It just says 3/7 of his monthly income. So, and this is just the answer we're supposed to get. That's kind of an answer key. So I can start off by saying, okay, let's let X equal the monthly income. Okay, and then you want to set up your equation. EQ will stand for equation. So you're going to take 3/7 times X. That's his monthly income. And then it's going to equal. So if the school he would like Taylor to attend costs $1,200 a month, okay, so $1,200 a month, okay, then what monthly income does Jim need to be able to afford the school? Okay, so this is how we would set up this equation. Okay. And what I also like about this is that look at the coefficient. See how that's a fraction? This is a fraction coefficient. A fraction coefficient. So I hope you remember what I would like to see. What I've been teaching from my perspective is that if you solve an equation, and we are solving this, and you have a fraction coefficient, what I've been stressing is that you use this to use that rule of the multiplication principle. You want to use the multiplication principle or the multiplication property or principle, and you want to find yourself multiplying both sides by its reciprocal. Okay. So you're going to multiply this side and this side, both by its reciprocal. And it's the reciprocal of the coefficient. It's the reciprocal of the coefficient. So I'm going to ask, what's the reciprocal of 3/7? And you want to say 7/3. So reciprocal just means you just flip it. It doesn't, don't say negative, don't say -7/3, okay? Don't say that it's -7/3. That's not true. It's not telling you to take like opposite reciprocal. You don't take the opposite sign and flip it. No, you just flip it. Okay? So this is positive, so it's still going to be positive. If this were negative, then it would still be negative, okay? And you're just flipping it. So I'm going to show multiplying both sides, and I'll change my ink a little bit. I'm going to show in baby blue here, multiplying by 7/3. 7/3 times 3/7 equals 1200 times 7/3. Okay. All right. And then when you multiply fractions, you multiply straight across. 7 times 1, 7, 14, 21. This is 21 over 21x. But 21 over 21 is just, this divides into each other, and this is just x equals. Okay. Or what happens too, people say, is that they see this here and they just say, 3 goes into 3 one time, 3 goes into 3 one time, 7 goes into 7 one time, 7 goes into 7 one time, and all that just has a whole bunch of ones. 1x. Okay. Now on this side, you want to multiply straight across. This one you can put it as a fraction over 1, so it looks alike, and you want to multiply straight across. There is an imaginary 1 always underneath these counting numbers. They just don't bother writing it. Okay. So you multiply across. So 1200 times 7 is 8,400. And 1 times 3 is 3. And then it turns out that 8,400, when you divide it by 3, gives you 2,800. And the comma is actually optional. There is a comma rule that says commas are required if you have 5 or more digits, and it's optional if you have 4. So you see 1, 2, 3, 4 digits. Comma is optional. You can put the comma or leave it off. But when the comma has 5 or more digits, then you say it's required. So if you like Jeopardy, that came out in Jeopardy one time on the game Jeopardy about the comma rule. Okay. All right. Okay. So if you're still writing, go ahead and pause the video. This is a recording, and write that down. Okay. And I'm going to just go on to the next problem. Okay. And I am going to look at the top of page 121, because there is some vocabulary up there too that I'm interested in looking at on this recording. So it says here that odd integers are integers that are divisible by 1. Okay. Odd integers are integers that are divisible by 1. So, I mean, usually 1 is very trivial. Usually when we divide, you want to divide by something other than 1. So it's an interesting question, but the book does say that it's false. It says that odd integers are integers that are not even. Odd integers are integers that are not that are divisible. Okay, so I'm not really sure. I'm not really sure exactly what they're getting at. We usually, when we try to, we, you know, a number is, the factors of a number are one times itself. And we usually don't bother dividing by one, because when you divide by one, you get itself back. So yes, that's not a very good question. I'm not very interested in that. So don't worry so much about that. Let me see this one. Even integers are consecutive if each is 2 more than the previous even integer. Yeah, and that sounds familiar. That sounds familiar. If you go back to your vocabulary here about these even integers, that kind of sounds like this, right? 2 more than the previous integer. That sounds familiar. Yeah, now that we're putting is true. Okay. Okay, now let's look at some of these problems here, and let's start off with the ones that use our vocabulary. So let's start off with this one here, number 7, because I see right away 3 consecutive integers. Okay, so I'm going to skip over these. These are not consecutive or consecutive even, consecutive odd. They don't, you want to look for that vocabulary. So this says 3 consecutive integers, and their sum is 93. When you add them up, you get 93. Okay, so I'm advising you to do a little list. You've got 3 of them. So you have the first, and I use CI. First CI is N. Second CI is N plus 1. And you're like, well, how did she know that? Well, because I've got my vocabulary. See, CI, consecutive. First one is N. Second one is N plus 1. Next one is N plus 2. You have to make sure you use the correct vocabulary. And that's from Go Languages. N plus 1. And then the third one is N plus 2. And then you're taking the sum. So when you write your equation, the idea is that the first CI plus the second CI plus the third CI is equal to the total. That's the idea. And then you're going to substitute. So the first one is N plus the second one is N plus 1 plus the third one is N plus 2. And then that equals the total, which is 93. Okay. And then now you have to combine like terms. Okay, so you see how you have N plus N plus N. And although the book doesn't put ones, they're there. 1N plus 1N plus 1N. That's 3 of them. That's 3 N's. So 1N plus 1N plus 1N is 3N. And then you want to combine your constants. 1 plus 2 is 3. So 3N plus 3 equals 93. Okay, now I'm going to solve for, I'm still solving for N. So now I'm going to subtract 3. And the 3's fall out. And I have 3N is equal to, and 93 take away 3 is 90. And now I'm going to divide by 3. So now I'm going to do, I really don't want to work on this space. I'm going to come over here. I really don't want to ruin that space. So I'm going to say 3N divided by 3 equals 90 divided by 3. And so N equals, and I'm going to use my calculator, and 90 divided by 3 is 30. Okay, and that's only one of your answers. See, they want you to find all three of them. And you found this one. The first one is 30. Now you need to find the other one. So you just do a substitution here. See how this, that's why I have you do the labels. So this is n plus 1. You already know n is 30. So this is just 30 plus 1, which is 31. Okay. And consecutive means, like, remember, a 1 right after the other. So 30, 31, and then the next one should be 32. So the next one is n plus 2. So let me move this closer. Next one is n plus 2. N plus 2. So that's 30 plus 2. And 30 plus 2 is 32. So make that bigger. So n plus 2 is 30 plus 2, and 30 plus 2 is 32. So these are your three answers. And probably the book will want you to probably separate them with commas. So they probably want 30, comma, 31, comma, 32. That's probably what the computer will tell you to do. And if you check them and you add them, 30 plus 31 plus 32, you do get 93. Okay. Okay. Let's see. I do want to do A, but not right now. Let me do some of the other consecutive and consecutive, even consecutive odd. Okay, so we did 7. Okay, and let's do. Let's do page 124. Let's do number 2, because see, it has consecutive even integers. Okay, that's also using your vocabulary, right? Okay, and look, you're only working with 2 of them. So when you do your labeling, you only have first C, E, I equals. So remember, I use the first letter of each word here. So the first one will always be N on these type of problems. Then the second one, C, E, I. Okay, so then you look at your vocabulary. CEIs, see? CEI for consecutive even integers. The second one has got to be N plus 2. That's what they're telling you. That's what they're instructing you to use, N plus 2. Okay, and now when you might make your equation, the idea is that the first CEI plus the second CEI is equal to total. Okay, well, the first one, and you're going to substitute. The first one is N, plus the second one is N plus 2. And then your total is negative 74. See that? And then now you're going to combine like terms. So if you look at your n's, n, 1n plus another 1n, that gives you 2 n's. So n plus n is 2n. And then your constant, you only have that constant of 2. And then it equals negative 74. Okay, now you want to solve for n. So you want to subtract 2 from both sides. This falls out. 2n equals. And this is rule number 1, right? you're adding two negative numbers. Remember, there's like a little plus sign here, remember? So you're supposed to, remember, add, and you're supposed to keep the negative. So that'd be negative 76, okay? And then you're going to divide by 2. And then when you get your calculator and you divide that out, negative 76. So remember the negative is down here. Negative 76 divided by 2 is negative 38. And that's only the first one. You've got to find 2 of them. That's the first one. And it is even, right? Negative 38, right? That's an even number, right? In even numbers, remember, even numbers in a 0, a 2, a 4, a 6, or an 8. So it is even, just happens to be negative, but it is even. And they want you to find the other one. So to find the other one, that's why your teacher wants you to do a little label, because you just come over here and you substitute. You already know n is negative 38, so you just do a substitute. So you have negative 38 plus 2. And that gives you a negative 36, doesn't it? This is rule number 2. Whenever you're adding 2 numbers with different signs, you're supposed to subtract, right? 38 take away 2 is 36, right? And then you're supposed to keep the sign of the number with the bigger, larger absolute value. These two are competing for signs. The 38 is farther from 0 than this, so it's going to be negative. Okay. All right. Okay, so those are your 2 numbers, the negative 38 and the negative 36. Okay. Okay, now let's do this one. The sum of 2 consecutive odd integers. Okay. So again, you only have 2 of them. So when you're labeling, first COI, okay? And that's going to be n. All these for consecutive, even, consecutive odd, they all start with n. And then your second consecutive odd integer, okay, go to your vocabulary. You're going to have the sheet out when you take your test. COI, okay, that's down here. Consecutive odd integers. Okay, first one is n, and then look, the second one is n plus 2. And you're following directions. This is, I know this vocabulary is identical to this vocabulary, but that's how it works out, and that's what you were told to use. So just don't worry about that. This is going to be n plus 2, and it'll come out in the wash. It'll come out. See, these are odd, these are even. The beauty of it is it works out. So the second one is, trust me, it's n plus 2. Okay, and then your equation, the idea is that when you add the first consecutive odd integer plus you add the second consecutive odd integer, that's supposed to equal your total. So when you do your substitution, the first one is n plus, the second one is n plus 2, and then the total is 128. Okay. And so now you're going to combine like terms. So on your test, when you're working this, you don't have to write these steps like substitute, combine like terms, okay? And then this is like using the subtraction property. So here we were using the subtraction property. And then here we were dividing by the coefficient, which was a 2. So on the test, you don't have to write these sentences. It's just, I'm your teacher, so I'm writing these steps because I want you to learn the procedure. But on the test, so you should do your labeling, and you definitely need to set up your equation. You definitely need your equation. So if you don't want to start with this description, that would be okay. But you need to make sure I need to see this. I need, to see that, this setting it up, solving it. None of this, I can do it in my head stuff. If you can do it in your head, that's great. You do that as a check. But for the teacher who's taking a test and we're teaching you solving equations, setting them up and solving, I need to see this process, okay, for the full credit. Okay, so in, one in and another one in, that's two of them, that's two in. And then plus two equals 128. Okay, and then, and if you want to pause or stop the video, you can pause or stop it and then you solve it. And then when you're done, you turn it back on and then let's see if we get the same thing. You can do that. I'm gonna just keep going. I'm gonna subtract 2 on both sides. This falls out. 128 minus 2 is 126 equals 2n. Okay, so here I use the subtraction property. And now I'm going to divide by the coefficient. And I'm going to divide by 2 itself. Don't divide by 2n. Don't divide by 2n, just divide by 2. Divide by 2. And these fall out. And then what's half of 126? 126 divided by 2 looks like it's 63. Okay. And that's looking real good, right? Because that 63, that's odd, right? It's an odd integer. Odd integer. It's not even. Remember, evens end in 0, 2, 4, 6, or 8. Otherwise, if it's not even, it's odd. So that looks good. But that's only one of them. You've got to find 2 of them. So to find the other one, you use this list here and you do a sub. And this is 63 plus 2, which is 65. So those are your 2 numbers, 63 and 65. Okay. All right. Okay, let's see. I think there's another one on the other page. Let's see. Yes, number 4. See, we'll do this, and then we'll go back to that other one. So 3 consecutive even integers. Okay, so here you're working with 3 of them. Okay, so you have first C, E, I. And I'm just using the first letter of each word. That's N, right? All of them start, all of these type, right? All of these start off with N. They have all that at least in common, right? Okay, then the second consecutive even integer is, and then we'll look that up, CEI. So you're gonna go here, CEI. First one's N, next one's N plus 2, and the third one is N plus 4. So you have to use what the vocabulary tells you to. So we have to say the second one's N plus 2, and then you have to say the third one is N plus 4. You have to. So third CEI. Okay. Okay, then your equation, let me put your equation over here. So then the idea of your equation, the idea is that you're taking the first one, the first CEI plus the second CEI plus the third CEI. Oh, I'm running out of room. And it's going to equal the total. Rats. So here, equation. The first CEI plus the second one, CEI, plus the third CEI, which is consecutive even integer, equals the total. So then we're going to sub. So you got N plus N plus 2 plus N plus 4, and it equals a total of 222. Okay, so this is what your teacher wants to see. If you only like do this in your head, try and solve it in your head and play with numbers, you won't get the full credit. We want to see you setting up an equation. So if you don't want to write this part out, that's fine, but you should start, I need to see your equation. You need to have this. You should also do your little list here because you're going to have to go back and find the second and third number. Okay. So now you're going to combine like terms. So you have n plus another n plus another n. Okay, that's a total of 3 of them, 3 n's. So that's 3n. Now your constants, it looks like you have a 2 and a 4. Okay, that's 6. And then it equals 222. Okay. Okay, then you subtract 6 on both sides. This falls out. 3n equals. So you're using the subtraction property. And again, this is where you're on video, you're looking at a video, you can pause the video and then you solve it. And then when you're done, you turn it back on and then see if we got the same thing. Okay, I'm going to keep going. So 222 take away 6 is 216. And then you're going to divide by the coefficient, which is 3. Just divide by 3. Do not divide by 3n. Do not divide by -3. Okay, it's just divide by 3. 216 divided by 3, 72. So another thing to mention is that if you were to, for what you're doing, integers, consecutive integers, consecutive even integers, consecutive odd integers, you shouldn't be getting decimals here. The integers, a decimal is not an integer. So if you're getting decimals here, then there's something wrong with your setup. Either you have the wrong vocabulary, or you added instead of subtracted, or subtracted instead of added, or you made an error when you did that calculation, or you didn't divide by the right number. So you shouldn't be getting decimals here. These are integers. Okay? So you got to go back and look for your mistake if you did that. Okay, so now you only found one of them. You need to find 3 of them. So you come back over here, and this is going to be 72 plus 2, which is 74. See, that's looking good. See, even ends in 2, ends in 4. That's looking good. And then this one is 72. Remember, it's n. N is 72 plus 4, which is 76. Okay. So there are your 3 consecutive evens, 72, 74, 76. And if you do a check, if you add those up, 72 plus 74 plus 76, 72, 74, 76, and it equals a total of 222. See that? Beautiful. Okay. All right. Okay, now there was another one that involved the idea of consecutive even, consecutive odd. There was this one that I wanted to go back to. This one is a little bit harder because the other ones are a little bit easier because you're just adding them up. The sum, adding them up, and equals a total. This one, you're manipulating it a little bit differently. So I just wanted to show you this. I wouldn't put one like this on the test because it does take a little bit longer, but you might have it on your practice. You may not have it on the certified, but it might show up on your practice. So that's why I'm not going to skip it just in case. But I wouldn't put this on a test because it does take a little bit longer, but you have to know your vocabulary too. So, but this just show you how things can be manipulated, okay, besides just the sum, okay? And look what's happening here. They want you to find 3 consecutive odd integers. Okay, so you're working with consecutive odd, and you know you have 3. So in your label, you should start off with first COI equals N. Second COI equals, okay, and remember COI, consecutive odd integers, see, N plus 2, N plus 4. That's what you have to use. N plus 2, N plus 4. So remember that. N plus 2, and N plus 4. So you have third consecutive odd integer. Okay. All right, now look how you're manipulating. You're not just taking a sum. Look what's happening. Look what's happening. There's a combination of things happening. Find 3 consecutive odd integers such that the sum of, okay, the sum of twice, you know, twice means times 2. Sum of twice the first. Okay, so you're going to go to the first one and you got to take times it by 2, multiply it by 2. So this right here, twice the first in your equation, that means you're doing 2n. Okay, and then they said it was a sum. They said it was a sum. So there's your sum. And then the word and means, okay, what's the other thing that you're summing? So the other one is 3 times. So you're doing 3 times the second, 3 times the second one. Okay, well, the second one is n plus 2. See that? See how you're manipulating that? So you are taking a sum, and it's twice the first, so 2 times n, and then it's 3 times the second. 3 times the second, which is n plus 2. And you do need parentheses because this is a binomial. You don't need parentheses here. This is a monomial n, but you do need parentheses here. And then is in math, is the equal sign in math. Is the equal sign. And then is 7 more than. Okay, so more than, you know, more than is plus, right? More than. And then really more than, technically you write it in a reverse order to be prim and proper, more than. So really the 7 goes in the back. Okay, if you forget and you put it in the front, you can still get the right answer because it's addition. But if it were subtraction, you wouldn't. So 7 more than twice the third. Twice means times 2, twice the third. And the third is n plus 4. Okay, so 7 more than twice the third. And the third is n plus 4. Okay, and voila, there's your equation. Okay, see how it's pretty cool, huh? They're manipulating that. Okay, when it comes time to the check, it's not easy to do a check on this one. When you do the other ones, when you're just summing them, you add them all up and it gives you a total. Those are easy to check. This one, you really won't be able to check this one. You just read and reread. See how I read and I reread my vocabulary and I box and I highlight things. That's the way to check it with that vocabulary. But now you want to solve this, okay? So remember, first thing you gotta do is your distributive property. So see 3 times n, so you have 2n plus 3 times n is 3n. 3 times 2 is 6. 2 times n is 2n. 2 times 4 is 8, and then plus 7. Okay. So I'm doing my distributive property. And this makes it a little bit easier because at least they're all positives. They're all positives, no negatives. Okay. So then next thing you want to do is combine your like terms on the left side and combine your like terms on the right side. So combine your like terms on the left side and then combine your like terms on both sides on the right side. So if you want to pause the video now, you can pause it and start solving for n. Solving for n. Then when you turn it back on, we can double check our answer for that. Let's try to see if I can find it right quick. I thought I had it written down. I don't think I have it written down right over there. Okay, but go ahead, you can do that. I'm going to go ahead and continue. So if I add the 2n and the 3n, 2n and 3n is 5n. So this gives me 5n plus 6. Over here, 2n plus 8 and 7 is 15. Okay. Okay, now I'm going to start moving things over. And I'm going to have to use like the addition and subtraction property, but twice, like one on the variable terms and one on the constant terms. So what I'm going to do first is I'm going to move the 2n over first. So I'm going to subtract 2n. And then these are going to fall out. So 5n minus 2n is 3n plus 6 equals 15. But now I'm going to use the addition, or no, the subtraction property. And now I'm going to move 6. So the opposite of 6 is a take away 6. Take away 6. And then the 6's fall out. So now I have, let me come over here. Now I have 3n. Let me move this over. So now I have 3n equals, and what's 15 minus 6? Isn't that 9, right? 15 minus 6 is 9. And then I'm going to divide by 3. And then n equals 3, right? 9 divided by 3 is 3. So n is 3, okay? N is 3. And that's the first one. That you found the first one. But if you have to find all of them, the first one is 3. The next one is 3 plus 2, which is 5. N plus 2, n is 3. 3 plus 2 is 5. And then the next one is n plus 4. So n is 3 plus 4, which is 7. So now you have 3, 5, and 7. 3, 5, and 7. Okay. And then that's how you work those. Okay. All right. Now, these two, I'll go back to these two in a little bit. Let me do the text problem, the ones that the math department made. Let me go back to the text problem. And I'm going to go ahead. I'm on page 125. Page 125. And I'm going to go ahead and write the formula down from page 119. I'm going to write it down. But when you're taking the test, you don't have to write the formula down because you're going to have it on your paper that you can use. But then you want to start doing the substitutions. But I'm going to write the formula down. So it's formal. So you have your initial fee plus the extra charge, open parentheses, the monthly messages sent. That's the unknown, minus the first set allowed, close parentheses, equals amount. Okay. So Megan owes $66.25. Okay, so that goes under the amount. For text messaging in the month of May. If her text messaging plan costs $13, so that's the initial fee. For the first 450 messages, so right here, remember we said this is the unknown. How many text messages did she send? Monthly messages sent, that's the unknown. That's, somebody's got to be the X, so that's the X. Minus, and then the first set allowed, so that's a lot of messages. She's allowed 450. But if she goes over that, then they're going to charge her 25 cents. So that's the extra charge, 25 cents. So this is important. Do y'all know that 25 cents is 0.25? That's important. Sometimes this is where the students make a mistake, is right here with the charge. Sometimes they just put 25. If they only put 25, 25 means $25. They're writing that wrong. If they were to say a nickel is 0.05, or I should say 0.05. That's a nickel. Okay, that's 5 cents. Okay, sometimes people make a mistake with the pennies. If I say 0.09, that's 9 cents, 9 pennies. So you do want to be careful here, because if you write 9 means $9. So you do have to be careful. That's kind of where the mistake is made. Usually if something is 13 cents, usually they don't make a mistake. If it's 13 cents, they know that that's 13 cents. Usually they don't make a mistake with that, but these that have the zeros in them, or like $25 versus 25 cents, I've seen mistakes often. So just be careful. Okay, and remember what you're doing is you're solving this. You're solving that for X. So you want to do distributed property. 25 cents times X. So you have 13 plus 0.25 times X. 25 cents times a negative 450. So you know that's a negative. Different signs have negative results. So 0.25 times negative 450 is a negative 112.5, and then equals $66.25. And then now you're going to combine like terms. So this is where you can pause the video. You can pause the video and finish solving it, and then turn it back on and then check your work. Okay. So I'm going to continue going. I'm going to combine my like terms, and I'm going to combine the 13 and the minus 112.5. And I can use a calculator for that. So I have 13, take away 112.5, and see how that's being negative. You're adding two numbers with different signs, basically, right? Because this is like adding the opposite, right? So this is like 13 plus a negative 112.5 plus 0.25x equals 66.25, right? So you're adding, this is rule number 2, rule number 2. So it's going to be negative. You're going to have to subtract. Okay. And then now, after you combine like terms, then we're going to start using your addition or subtraction principle. So we're going to move that opposite of 0.25 is a minus. Actually, pardon me, actually that's fine. We need to move the 99.5. see. So we actually need to move this one and do opposite. So do plus 99.5. And you can put a little 0 here. You went behind that. And you want to put 0, you could do that. Let's add those up. 66.25 plus 99.50. Wow, it's 167, no, 165. 75. Okay, so you have 0.25x equals 165.75. Okay, so we come back over here. Okay, I'm gonna divide both sides by 0.25. No x, just 0.25. 165.75 divided by 0.25 is 663. And that's your amount of text messages sent. Okay. So you might have to practice that a couple of times and work on your speed for that. Okay. All right, now. Okay, now I'm going to move on to number 6. Okay, so this says that if you buy a jacket and you buy a tie, that you have this total cost, and they say the total cost is going to be $52.17, but you don't know how much is a jacket and how much is a tie. So when we do our labels here, you need to find out who is the unknown. Is it the jacket, or is it the tie? One of these is X, one of these is X, the unknown, and one of these is described in terms of the X. So if the price of the jacket was $1.71 less than the tie. Okay, well, you know something about less than. Less than means to subtract. So right here on the jacket, to subtract in a reverse order. You know that, to subtract in a reverse order. So the 171 should be, in the back from your training on your vocabulary. And then the tie is, that means the tie is the unknown. The tie is going to be X. The tie is going to be X. We don't know what was the tie. They didn't tell us anything about the tie. So somebody's got to be the unknown. So the tie is the unknown, X. So you do your substitution, and the jacket is described in terms of the tie. So the jacket is described in terms of the tie, and the X is the unknown. Now, you know how in the past your teacher has highlighted the unknown? That's the unknown. That's your X. Okay. And then the jacket is X, take away 171, because it was a little bit less expensive. It was a little bit cheaper than the tie. Okay, so now you're going to, this is your equation that you're going to solve for. So now you're going to combine like terms. Don't try and add opposites. You have to first go in order in the procedure and combine like terms. So you have an X and an X and another X. That's two X's. This X and this X is two X's minus $1.71 equals $52.17. Okay. And now this is where you can, stop the video and finish solving for X. And then when you turn it back on, we can check your work. Okay, I'm going to keep going. I'm going to add opposites. So I'm going to add a plus 1.71 to both sides. This falls out. 2x equals, and I'm going to add that up. 7 and 1 is 8. 7 and 1 is 8. 2 and 1 is 3. Looks like 53.88. And then I'm going to divide by 2. X equals, and I'm going to use my calculator for that. This is fine. 53.88 divided by 2 is $26.94. Okay. And what is that the cost of? Is that the cost of the jacket, or is that the cost of the tie? See that? That is the tie. The tie is X. So in this problem, you have to know, what are they asking for? Are they asking for both the tie and the jacket? Or are they only asking for the tie? Or are they asking for the jacket? Sometimes people miss it because they have all this work correct, but when they type their answer in the computer, they don't answer what they want. The computer the question is, what was the price of the jacket? They only want the jacket, and you found the tie. So you need to go over here and find the jacket, which remember was X minus 171. So the jacket is 26.94 minus 171. X minus 171. 4 minus 1 is 3. 9 minus 7 is 2. 6 take away 1 is 5, and then that's 2. So it looks like the jacket was $25.23. And then this one you could check. If you add them both up, $26.94 plus $25.23 was $52.17. Okay. So it's interesting because the very expensive tie, notice how the tie ended up being more than the jacket. That's interesting. So so maybe the tie must have been an expensive tie, maybe a Ralph Lauren or something, or Calvin Klein or something. Or maybe the jacket had a really good coupon, a real good coupon from Macy's or something, right? Okay, either way, that's that problem. Okay, now let me go back to number 1 on page 124. Okay, so these are the type that the title says applications, number problems, and consecutive integers. And then there were some other types of problems as well. I would say that number 1 is one of those number problems. I would say number 1 is one of those number problems. So it says some number minus 6. Okay, so in our vocabulary, remember you had your vocabulary for subtraction. Minus just means to subtract in a straight forward manner. So some number, I'm going to call that X, minus 6 is the equal sign, is equal to, product means multiply, and you're multiplying that number and 17. So that means this. X times 17, 17 times X, okay? All right. And then we're gonna solve that. We're gonna solve that for X. So here, what I would do is I would move this X over here. Okay. I'm gonna add X, I'm gonna subtract X. And subtract 1X, right? These fall out. And you have -6 equals 17 minus 1X is 16X. Okay. So now you have your variable terms on one side and then your constants on the other. Okay. So, and you can do that. Usually the teachers try to move the letters on this side usually, but sometimes it's more efficient to move the letters over here to the right side, you know, depending on how many constants you have. So you only have this constant of -6. So you only have to use the addition subtraction property once. We're using the subtraction property. And that's good. That's good enough. You have letters on one side, constants on the other. And now you're going to divide by the coefficient. And the coefficient is the number in front of the variable. So make sure you divide by 16. Don't divide by -6. -6 is the constant. You don't want to divide by the constant. You want to divide by the coefficient. And then this can be reduced. -6 over 16 can be reduced by 2. So -6 divided by 2 is -3. 16 divided by 2 is 8. And so that looks like X equals -3/8. And that's okay. That can happen. You can get a fraction. It just said some number. It's not like the consecutive integers, consecutive even, consecutive odd. Those they're integers. You have to get integers. There you cannot have fractions. You can have decimals on those. But this it just said some number. So that's fine. That could happen. Okay, -3/8. Okay, and then the other examples of the number problems, going back to page 121. 121, let's look at number 5. Okay, go ahead and read number 5 to yourselves. Five less than a number. Okay, less than means to subtract in a reverse order, right? So less than means to subtract in a reverse order. So this 5 needs to go in the back. So 5 less than a number, so I'm going to just call that X, okay, is equal to 13 decreased by. So decrease means to subtract in a straight forward manner. It's not one of those special ones where you have to write in a reverse order. So this one's 13 minus 13 decreased by the number. Okay. And now you want to solve that. This is your equation. This is your equation. That's what you want to solve. Okay, so see how you have two variable terms and say you have two constant terms. You're going to have to use the addition and subtraction property, like do it twice. Okay, so I'm going to move this X to this side. So I'm going to do plus X, and these fall out. So X plus X is 2 of them, 2 X's, 1X and 1X is 2 X's, minus 5 equals 13. I'm gonna write that over here. 2x minus 5 equals 13. And now I'm going to have to use the addition subtraction property again. Now I'm going to move the minus 5 over. And the opposite of minus 5 is a plus 5. And this will fall out. So you have 2x equals, and this gives you 18. Okay. So I had to use, I used the addition property here. So I use the addition property. And then here I also use the addition property again. But I had to use that addition property twice, right? Because you had two variables and two constants. So that means you have to get ready to use that twice. You're either adding something or subtracting something, but you got to do that twice. Okay, now I can divide by 2. And now x equals to 9. And that's the number, 9. Okay, this one, twice the number. So, you know, twice means times 2. So twice the number, I'm just using x. Twice the number. Sometimes they tell you up here what letter to use. Sometimes they tell you to use the variable x or use the variable y, but they didn't. They didn't tell you what to use. So I'm just going to use x. Twice the number, increase means plus by 3 times the number is equal to, okay, so twice the number means times 2, increase by 3 times the number is equal to 4 times the sum, 4 times the sum of what? The number and 3. See that? That's nice, okay? 4 times the sum of the number and 3. So yeah, you need distributive property here for this binomial. Okay, and that's half the battle, is setting it up. That's your equation, and that's what you're solving for. Okay, so if you want to pause the video, you can pause it and then solve it, and then see if we get the same thing. And I'm going to just keep going. So I'm going to do distributive property. 4 times x. So you have 2x, or actually you have 2x plus 3x. So if you don't mind, I'm gonna just go ahead and say that's 5x if you don't mind. And then I gotta do the distributive property. 4 times x is 4x. 4 times 3, that's 12. Okay. And then now I'm going to move the 4x. I want all the letters on one side, all the constants on the other. So the way you move terms is you do their opposite, minus 4x on both sides. And these fall out. 5x minus 4x is just 1x, and that equals 12. So then you just have x equals 12. That was short and sweet. Okay, once you got over this, setting this up, I think setting it up was a little harder than solving it. Okay, well, we got that done. All right, and then the last problem I want to do is on your extra page. You have an extra page. So you can pause the video, you're still writing, but I'm going to go to the last column and finish. Is on page 123, and I want to show you this problem. 1/16 times m plus 8 equals negative 1/4 times m plus 4. All right. Okay, so in the past, sometimes students bring up like questions that they come across in their practice. And I'm like, oh, we didn't put one of those in the workbook. Right? That's a good one to show students. And this is one of those problems that I like to show students here, that first, to solve this for m, you're going to do distributive property. So you got 1/16 times m is 1/16 m. And then you got 1/16 times 8 over 1, right? When you do that. And you know how to multiply fractions, so you have to multiply across. So you have 1/16m plus 1 times 8 is 8, and 16 times 1 is 16. Okay. And then also this can be reduced by 8. So you have 1/16m plus 8 divided by 8 is 1. 16 divided by 8 is 2. So you're reducing them. Okay. So this is good on this side. Now over here, now you're going to do distributive property on this side. -1/4 times m is -1/4 m. -1/4 times 4 over 1, right? 4 over 1. And you're going to multiply across. Okay. So I'm just going to bring this down. This is -1/4 m. But here I'm going to work with this. So -1 times 4 is a -4. And 4 times 1 is 4. And you see this -4 over 4 is just a -1. Okay. Okay, so then now I'm going to move this m to this side. So I'm going to add 1/4 m plus 1/4 m, and this falls out. This is just equals to -1, and this is right here plus 1/2. But whenever I add and subtract fractions, I have to find the common denominator, and it looks like the denominator is 16. 16 is just 16 times 1 is 16. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. You see how these match? So the least common multiple, which is the least common denominator, is 16. So I'm going to get ready to build this up. I'm going to multiply these. And put my fraction bar over here. And for 16, that's just 1. 16, that's already a common denominator. This times 1. So that stays 1/16m. But this gets built up. For 4, how many multiples of 4 do you have to get to 16? 1, 2, 3, 4. 1, 2, 3, 4. So you need to multiply these by little 4s. 1 times 4 is 4. 4 times 4 is 16. And then with regards to m. So you have 1/16 plus 4/16. And 1 plus 4 is 5. That gives you 5/16 m. 4 and 1 is 5/16. Keep the denominator. Okay, so now we're going to move this over. And we're going to move this on this side. So we're going to subtract 1/2 on both sides. And then this falls out. So you have 5/16 m equals. Okay, so here, when you add a -1 plus a -1/2, that gives you a -1 and 1/2. A -1 plus a -1/2 is just a -1 and 1/2. Okay, let's hold -1 and half. Negative and negative is a negative. So this is just -1 1/2. And then I'm gonna do this times and plus. So I'm gonna make that this is a mixed number. I'm gonna make into improper. Okay, so I'm gonna do this on the side. So this is gonna be 2 times 1. So 2 times 1. So you ignore this negative here. 2 times 1 plus 1 all over 2. So 2 times 1 is 2 plus 1 over 2. And that gives you 3/2. But it's going to be a negative. So now you have 5/16m equals -3/2. Okay. 2 times 1 is 2 plus 1 is 3, 3/2, and it's going to be negative, see? Okay, so now this is what you have. And you see, I like this problem because again, here's your fraction coefficients. I hope you remember when you have a fractional coefficient, you're gonna multiply by its reciprocal. Okay, so the reciprocal of 5/16 is 16/5. So you want to multiply this and this by 16/5. So if I change my ink a little bit, 16/5 times 5/16 equals -3/2 times 16. So see, basically these just divide out, right? And that just gives you n. Or if you multiply across 16 times 5, I think that's 80. 16 times 5, yep, that's 80. So then that's 80/80m, but then that divides out, and that just gives you n. And then when you multiply the other side, -3 times 16 and 2 times 5. So -3 times 16 is a -48, and 2 times 5 is 10. And then you just reduce by 2, let's try by 2. -48 divided by 2 is -24, and 10 divided by 2 is 5. Okay. So then this is -24/5. And this is improper. And if they want a mixed number, you would do long division. 24 goes inside the house. 5 times 4 is 20, and 4 is your R. And this gets recorded clockwise. So M is a negative, see, -4 and 4/5. And there's your mixed number. All right. All right. So I know that was kind of fast. I had a cup of coffee. I get dozed off. So I have a little cup of coffee that helped my caffeine, but then it also got me going kind of quickly on this recording. But I also didn't want to lose internet connection. So you can go back and review the video, go back a little bit and review me working the problem again. That helps you. So I hope that helps. All right. Good luck with your studying. Don't be a stranger to Math World. Math World, we have people hired. They work pretty much from, I think, 8 to 7. College president wants the math tutors available to help. All they do is answer your questions. So they work as an adjunct instructor and they just answer your questions, okay? And so if you have questions, please pop in and see them. And then we have the college also pays to have online BrainFuse online in your Canvas course. They have 24/7 tutoring. Each student gets 300 minutes of service for tutoring. And so you've got your tools, you've got your app, your little app that takes pictures. You can communicate with them, send them your little PDFs of your work, and have that conversation going with the virtual. And then you also know how to print a screen on your computer. You got a print screen feature, right? Mine has PRT SCRN. I think you can print your screen of your problem in HOTS and then paste it into Word, and then send them that page as well, to get the communication going. So where there's a will, there's a way. And so it just takes a little bit of effort. And then, of course, I show all my steps and I have this video recording. And I hope that with you seeing me work these problems and showing the steps that you can also, get through maybe on your own without any extra tutoring. But if you need the tutoring, please don't hesitate to get the tutoring and with them, those resources, MathRow and online, BrainFuse online tutoring, let them help me help you, okay? All right, because there's only one of me, and then but we got a lot of support, the tutors and MathRow. There's quite a few tutors working this summer, okay? Okay, good luck with that, and just try not to procrastinate, okay? Try to start early on your homework because math always takes a little bit longer than expected, okay? All right, take care.